So in the last segment, we wound up with a 3D mesh that we were able to export. Now we're going to take that mesh and import it into PrusaSlicer, which is my slicer of choice. And what we're going to get out of this is a set of instructions that we can ship off to the 3D printer to produce the model in reality. So let's get into it. So as you can see, we've imported our mesh in PrusaSlicer, and everything is green, which means it's quite happy with this is printable according to the slicer right now. And just looking at this, we can see that things look pretty good. There aren't any obviously overly thin walls. We have our smoothing where we wanted it. Now, I have a whole bunch of different presets. So for this, let's think about what we're actually going for. This is a big part. So speed would be great. I'm very interested in strength though, because I do not want, especially this handle, to fail at any point. So I'm happy to have some extra infill and a good number of perimeters, which I think is going to pay dividends at the point where we smooth. All those extra perimeters layered on should give most of the strength, I think. And that infill should help kind of reinforce things. I think that a speed preset is okay for this part because I usually don't need quality presets unless I have some very small, precise, fine detailed features, especially on the lower layers. And really nowhere in this object are there any very fine features. So I think a speed preset is good. We don't need any waterproofing in my opinion, even if some of these drinks might have some condensation going on, the part might get a little bit wet. It's not going to be, submerged in water. It'll dry out really quick. I'm not concerned about that. And besides, we're already talking about extra perimeters. Those extra perimeters are kind of what go into the biggest part about making a waterproof part. So I really don't think that we have to do anything special for that. So what I'm thinking then is I think I probably want at least to consider a 0.15 millimeter layer height. And that's just because we do have these fillets. And especially for fillets, those are kind of curved smoothing features. And the lower the layer height, as this is being printed from bottom to top, the lower the layer height, the better those curves are going to be expressed. So I think that 0.15 is a good medium there, but let's actually just see what the print times look like. This might be, too much. So looking at my presets, I'm thinking 0.15 speed verbose G-code. In other words, the only modification that this really has is it enables verbose G-code, which I use for time lapses, the Octolapse Octoprint plugin for time lapses. If I go over to print settings, let's take a look. So what has changed? Solid layers, top 8. Do we need that for this print? I don't think so. Top shell is 1.2 millimeters thick. Minimum 0.7, bottom is 0.75 thick, minimum 0.5. I don't want to change the bottom solid layer count, but I think the top is a bit excessive, even though that's really a small feature. It's not going to dramatically affect anything, but I just don't think we need anything extra there. Seam position nearest, what is the default there? Aligned. I think aligned is a bit nicer. Clearly some of these from this preset have changed, and I like to stick with the slicer defaults where possible. So I'm actually going to be editing this preset a little bit. It might have been some time since I used it and updated the slicer. I do like the combine infill every so many layers feature at 0.15 millimeter layer height. I can do 2. It basically lets it print infill thicker. So instead of printing infill every 1 layer, it'll print it every 2, and it'll print it, taller, really. and that cuts down on print time handily. Fill density, when it comes to strength, in fact, I think I made a mistake. Do I have a strength preset on 0.15 only for quality? So I'm basically going to edit this for strength and actually add that in here. For strength, grid, I think that I usually use rectilinear for strength, but let me jog my memory. Yeah, rectilinear. There's an article that I've been referencing for this, and rectilinear in their, they actually have all the proper scientific instruments. They found rectilinear to produce the best strength. They also found that perimeters are the most, or the greatest influence on strength. For strength, I believe, let me just save this real quick, not as verbose G-code, but strength. And let me reference my quality strength preset. I believe 6. Yep. I actually do go as high as 6. Whether we need all that right now, I think it's debatable, but let's just see what the print times look like. It might be ugly, but let's see. And I also want to see what I was doing for infill percent 15. Yeah. Again, in this article, they showed infill is not the greatest influence on strength. So we can bring that down a little bit, but rectilinear was important. It was better. It beat out gyroid. It beat out other options. So we do want verbose G-code. I'm not, what did they change on the output name? This is fine. I'll take that. I'm going to rename this anyway, but like I said, I like to stick with the defaults where possible. They did apparently change some of the new Arachne perimeter generator defaults, so transition length 100%. They brought it down to 0.4 millimeters as default. To be honest, I haven't researched Arachne enough, but I'm going to go with their defaults and trust that they changed that for a good reason, and we'll see how it goes. And I think we're looking good for our strength preset. We might need to change this. This is kind of a big part. Oh, this isn't too bad. 1 day, 1 hour. I think that's acceptable. That's really not too bad. Nevertheless, I am interested in seeing, I mean, that is a lot of filament. So what could we change here? What happens if we reduce perimeters down to 4? $21 hours. That's a huge difference. Let's look at some of the layers. Yeah. I'm especially interested in seeing what it looks like right at the weak point. So I would really like those extra layers, especially for the handle. And I think that in the slicer, what you can actually do, and let's test this, I think that you can add overrides. So let's see. I don't do this often, so I don't have it memorized how to add it. Add modifier, cylinder is fine. So we'll bring it here. Well, let's scale it out first. We're just gonna make this really big, really tall. And now we just need to move it. And then move it up. Ooh, did not want to do that. Move it up more. Okay. So what I would like to do, center it again. I just want it on the entire handle. That looks pretty good to me. Okay. So for this, layers and perimeters, override 6 perimeters. Let's look at the slice. Okay, we're back up to 23 hours, but you know, that I think is acceptable. Oh, it looks like I have that off center quite a bit. There's probably a button to center this, but I'm honestly not sure what it is, and I can just do it manually. That's no problem. Let's reslice. Oh, and now we're back down to 21 hours. Interesting. That's wonderful. So it looks like all of the I guess in this case about 2 to 3 hour difference was due to having 6 perimeters at the base. Like I said, I'm not worried about strength down here. These perimeters, they don't need to be 4 should be fine. In fact, I think I can improve this even better by making the default 2 perimeters, and then the override remains at 6. What does that look like? 18 hours, even better. Let's see that slice, those layers. We have a simple standard 2 perimeters for the cup holder section. And one thing I will, well, I think this will work. And then the handle should have all the extra perimeters. I probably need to move it down very slightly. Minus 0.4 might be too much, but let's see. I need to research to see if there are any ways to do this a little bit more precisely. But what is the result? Look at that. Six layers just where we want them. So that strong rectilinear infill pattern. And in fact, you can actually see the feature of combining infill every 2 layers. I'm just going to go up 1 layer, 2. There was no infill added on this layer. And here it is. So that's the combine every 2 layers feature, saving us time. As far as infill percentage, do we need 18? I'm not, or 15%? I think that's fine. I don't think that it's a problem for it to be where it is. One thing we can consider, if we do kind of an overhanded grip, yeah, there could be some considerations for adding additional top layers. It probably won't even change the print time, to be honest. So 18 hours, 28 minutes. Bring that back up to what I used to use as a standard of 8 for strength. 18 hours, 56 minutes. I've added 30 minutes and just added some extra top layers. I don't have a problem with that. Another thing that we could do is ironing, but we would only want to do that at the top. Ironing is going to have the nozzle basically like dig into the layer lines to smooth it out and make it look very nice. It makes the tops look very similar to the part that looks that contacts the print bed. But that is prone to clogging, especially when you have a very large surface area. I think we could do it to the handle, but honestly, I don't think we need to do that. If I'm really interested, I can always sand it and do a little bit of heat gun treatment. But we brought down the use filament from almost half a kilogram to 350 grams. I'm okay with that. 19 hours, I'm also okay with that. One more thing that I forgot to mention. I am using just my generic PLA filament preset. And indeed, I'm just going to use simple PLA for this. I really don't think that this part requires any advanced materials, not even, say, PETG. I think that for, frankly, a lot of parts, most parts, PLA can be just fine. You can print it watertight. For household uses, which is kind of my focus, PLA almost always works. It's when you start to think about things that are exposed to elements, heat, or need extremely beneficial strength properties that I think that other materials really start to shine. But for this, I am just going to be using PLA, so I didn't even change that preset at all. So at this point, we've finished the slicing process. In other words, we've constructed a set of G code that we can ship off to the printer, which is going to tell it how to lay down the plastic filament and produce our part for real. So look out for that in the next video.